Hello, this is Professor Sartor, and I wanted to take a look at this question that got emailed to me this week. The question states, evaluate the integral, and we have the integral of x cubed square root of x squared plus 9 dx. So currently we're learning about the substitution method for solving integrals. And the advice that you'll typically hear is to allow an expression that is inside to be your u that you're going to do the substitution. So I'm looking inside this radical at the x squared plus 9. And once you've decided what you're going to let u be, then you calculate the derivative of that thing. So the derivative of x squared plus 9 would be 2x. And you would need to have that 2x on another part of the integral for that method to work. So you can see here that instead of 2x, we have x cubed. So our very basic substitution method is not going to work on this problem. But I thought it would be good to start off with an example like that so you can have something to compare to. A simple method versus what we have to do in this problem here. So I'm going to modify this problem just to show you how easy it would be if this were the derivative of the inside. So let's go up here. I'm going to change that to an x instead of an x cubed. So I want to work on the integral of x square root of x squared plus 9 dx. Okay, so once again, with this substitution method, the idea most of the time, not all of the time, is that you let u be something that is inside. So I'm going to let u be x squared plus 9. Then we're going to calculate the derivative, and we're going to use the differential form of the derivative. So this will be du equals 2x dx. So the derivative of x squared is 2x, and differential form is having this du and dx. So once we do that, we make a substitution, and we're going to substitute what's inside of the radical to be x squared plus 9. And then we're also going to substitute for the dx. So before I do that substitution, I need to solve for the dx. So I'll divide by 2x on both sides. That gives me dx equals du over 2x. So I'm going to substitute in for the dx. So once we do the substitution, you'll have this here. X square root of u times du over 2x. Now, if this is going to work out simply, if it's going to be the most basic substitution technique, you will see the other variable canceling out. So we can see the x's are going to cancel out. And I'm going to rewrite this a little bit cleaner. So starting off with this 2 here, this 2 is a constant. I'm going to pull that out of the integral, and since it's in the denominator, we'll write that as 1/2. And then I'm also going to rewrite the radical as the 1/2 power. So that's u to the 1/2 power du. And now I'm able to evaluate this integral with the power rule because I have a variable to a power. In the power rule, we add 1 to the power and divide by that power. So we're going to have 1/2 u to the 3/2. 1/2 plus 1 is 3/2. over 3/2 plus c. We'll clean this up. I'm going to clean this up by multiplying by the reciprocal. Here we're dividing by a fraction, so we'll multiply by the reciprocal. That's 2/3 times 1/2 times, with the u, you'll recall, u was the substitution that we've done previously. So u is equal to x squared plus 9. We have x squared plus 9 to the 3/2 plus c. The 2's cancel, and we have 1/3 times x squared plus 9 to the 3/2 plus c. So now that you've seen how the basic substitution method works, I'm going to show you the one that was asked by the student. So we have this integral here, and as I told you previously, we need for the other variable to cancel out, and it's not going to cancel out with the x cubed. The x will only cancel out one of the x's, not all of the x's. So we have to have a different substitution for this. And the substitution that I'm going to suggest is going to be the square root included in this. So it'll be the square root of x squared plus 9. Okay, so let me show you how this one plays out. I'm going to let u equal x squared plus 9 to the 1/2 power. I went ahead and I rewrote it in that exponential form. And I did that so it would be easier for us to calculate the derivative. So let's calculate the derivative. And again, we're going to write it in that differential form. So it'll be du equals 1/2 times x squared plus 9 to the negative 1/2 times 2x dx. So we had to use the chain rule to calculate that derivative. We calculated the derivative of the outside power using the power rule. Bring the power down, take one away from the power. We left the inside alone, and we used the chain rule by taking the derivative of the inside. Okay, so we have our derivative. Let's clean it up a little bit. You can see that these 2's will cancel out. So we'll have du equals x squared plus 9 to the negative 1/2 dx. And I forgot that x there, so we also have an x. Let me highlight what I'm talking about. So I forgot this x here. So now I'm going to, just like last time, I'm going to make 2 substitutions. And in order to substitute u and dx, I have to solve for dx. So I'm going to divide both sides by x times x squared plus 9 to the negative 1/2. I'm going to divide that on both sides. And that's going to give me dx equals du over x. Now let me pause here because this part right here has a negative exponent. I'm going to bring that to the numerator, which makes it have a positive exponent. So let me move this over. So it'll have x squared plus 9 to the 1/2 power. Now something nice happened here, and you'll notice that this part right here, this 1/2 plus, the x squared plus 9 to the 1/2 power is the same as the u that we used earlier. So rather than writing x squared plus 9 to the 1/2, I'm going to use u. So this becomes u du over x equals dx. A lot cleaner. Okay, and we have some more work to do, but I want to show you if we do the substitution right now, what happens. I'm going to substitute for dx. Maybe I should use a different color there. I'm going to substitute for dx, as well as the u that we talked about originally. So if I make the substitution right now, I'll have the integral of x cubed u times u times u du over x. I'll simplify this a little bit and you'll see that we have an x canceling here and an x canceling here, so now we have an x squared. And we have x squared u squared du. Now, we are still not ready to evaluate this integral because when we change variables from x to u, we need to change it all the way. We still have this x here, this x squared. So I'm going to make one more substitution, and I'm going to start with the original substitution that we made. U equals x squared plus 9 to the 1/2. I'm going to solve the equation for x squared. So I'm going to get rid of this x 1/2 power by squaring both sides. This is u squared equals the square root, which is the 1/2 power, and the square are opposite operations. They cancel each other out. So I have x squared plus 9, and then I'll subtract 9 on both sides and have x squared equals u squared minus 9. Okay, so now that I have x squared, I'm going to make my final substitution. So this x squared equals u squared minus 9 will get substituted into this x squared. We have the integral u squared minus 9 times u squared du. I've changed all the x's to u's, and I'll be able to evaluate the integral now. So let me show you how this one will work. I'm going to get rid of those parentheses by using the distributive property. That will give me u to the 4th minus 9u squared du. And now that I got rid of that multiplication, those parentheses, I can evaluate each term individually. So focusing on u to the 4th, I'm going to use the power rule, add 1 to the power and divide by the power. So that's u to the 5th over 5. For the second term, the negative 9 is a constant multiple, so just focus on the variable part. U squared, once again, we'll use the power rule, add 1 to the power, divide by the power. So that's minus 9 u cubed over 3. And then we need our constant of integration plus c. So reducing, we will have, let me write it a little bit different. I'll write it as 1/5 u to the 5th. 3 goes into 9 3 times, so this is minus 3 u cubed plus c. And one last thing to do here, we need to bring back the original variable. When we bring back the original variable, we're going to be using that original substitution. So this becomes 1/5 x squared plus 9 to the 1/2, and then all of that is raised to the 5th power minus 3 times x squared plus 9 to the 1/2 power, and then all of that is raised to the 3rd power plus c. We'll use one of our exponential properties and multiply the powers. I'm multiplying these powers together. and that would give me 1/5 times x squared plus 9 to the 5/2 minus 3 times x squared plus 9 to the 3/2 plus c. Let me zoom out so you have all the work there. So this is a very challenging substitution problem, mostly because you're using something for u that is not just what is inside a parentheses. Let me know if you have questions. Thank you for checking out my videos. Have a great day.